Hi guys, welcome to Geeks for Geeks practice. Let me. Can you please confirm that if I'm audible or not? Yeah, can you hear me? All right. So let's start with today's question. So today we are going to see a very interesting question that was recently asked in an interview in Amazon, and that is pretty interesting. Like it is an application of binary search, but the input which is there in the question, like what is the details, we'll see now. Like usually we apply binary search when the input array is sorted, right? Or let's say given number of elements in an array is sorted, like the basic understanding of binary search what we have. But today we are going to see something different, and like it's pretty much value adding. Okay, so let's begin. Yeah, let me share my screen. All right, so I hope you're able to see my screen. So this is the question. Like it says allocate minimum number of pages. Now, to read the description of this question, what is the note, the sample input and output, let's come to the whiteboard. Okay, so I'll explain everything to you over here. Let's have a look at it. So it is saying you are given n number of books. Every ith book has ai number of pages. So let's say, or let's take a sample input from our practice GFG portal. Okay, let me close this one. It is open in two web pages. Let's go over here. Yeah. So if you look at the first sample input and output, let me copy paste this over there, okay? That I'll be able to explain you in a much better way. All right. Yeah, let me just maximize this, or rather minimize this. Yeah, let me take this over here. Yeah. So I hope the text is visible to you. I'll maximize this a bit and take this to the right. Yeah. Let me take this to the top. Okay. So let's try to understand. We are given n number of books. Okay. So over here you have four books because your n is four. Every ith book has ai number of pages. So this is your a, and every ith book. So if you look at the indexing, this is my 0th index, right? So can I say this is my 0th book? Okay. So every 0th book over here has 12 pages. The first book has 34 pages. Second book has 67 pages, and third book has 90 pages. So I am referring with the help of indexing. All right. So this is n4. We have four books and we have number of pages in each books. Okay, let's proceed forward. It is saying you have to allocate books to m number of students. All right. So basically, this four books needs to be allocated to two students, right? Because m value of m is 2. So if I write this over here, 12, 34, 67, 90. These are my four books, and I need to allocate these to two students. Now, there are some more lines of question written over here. Let's go through them. So they are saying there can be many ways or permutations to do so. Pretty obvious because we have four books. Now you can either give first two books to student one, the third and fourth book to student two, or you can give this and this to student one and 34 and 90 to student two. Okay. Let's proceed forward and let's try to understand what the question is saying. So in each permutation, one of the M students will be allocated the maximum number of pages. All right. We will come to this line later. Okay. Like when we will form our permutations, then we'll come to this line. It says that in our permutations, M students will be allocated the maximum number of pages. It will make much more sense when I will explain you this statement with the help of this sample input. Okay, let's proceed forward. Out of all these permutations, the task is to find that particular permutation in which maximum number of pages allocated to a student is minimum of all those in other permutation and prints the value. Now this is pretty confusing. Okay, pretty confusing. Why am I saying this? You hear about maximum over here and again a minimum over here. Okay, so let's try to break it and understand. Let me explain it to you with the help of this in sample input. Okay, let's say one of your permutations is you have given student 1 book 12, and let's say you have given student 2 34, 67, and 90. Okay, so how many pages student 1 has to read, like in which the number of pages is 12. Basically, I have given student 1 the book with the page 12, so he or she has to read 12 pages, and this particular student has to read summation of 34, 67, and 90. So let's quickly do it. 34 plus 67 plus 90, right? So basically student who has to read 191 pages. All right, so it's 191 pages. Now let me take one more scenario. Let's take this as 12. 34 is read by student 1, and 67 and 90 is read by student 2. Now what is this? This is turning out to be my 46, and this is turning out to be 157. Okay. Now let's try to go back to this line and understand. So we have two permutations now, right? This is my P1 and this is my P2 for this particular sample input. So it is saying out of all these permutations, the task is to find that particular permutation in which maximum number of pages allocated to a student is minimum of those in all the other permutations. So over here, we have only two permutations, and maximum number of pages allocated in permutation 1 is 191, because 12 is obviously less than 191. In P2, what is the maximum number of permutation? Sorry, maximum number of pages allocated to a student is 157, right? So the question is asking that out of this, you need to return the minimum. Okay, so question is asking, like, if I consider only these two permutations, then the answer will be 157, which is not the answer for this sample input, obviously, because I have not considered other permutations. But just to give you an idea of this line, okay, what you need to do, you need to form all your permutations, check what is the number of pages distributed among your students, and in each permutation, first take the maximum allocated pages to a student, then out of those maximum allocated pages, take the minimum one. Okay, like it's pretty much what we can do in real or practical life is we are trying to lessen the burden on student. Okay, like no student should be burdened with a lot of pages. So what should be the distribution? What should be the proper distribution? Okay, so let's proceed forward and have a look at the rules. Okay, like how we can do the permutations, or is it general, like are there any rules or not? So let's have a look at it. So it is saying each book will be allocated to exactly one student. So this is our first condition. Okay, each book is allocated to at least one student. Each book allocated to at least one student, right? At least one student. I have mentioned it with ST. Each student has to be allocated at least one book. Again, it's the like same thing. Like you cannot leave a student without a book. Okay, fine. Let's read this note. It is saying return -1 if a valid assignment is not possible. Okay, we'll see that. Now, what I wanted to explain you this is this part. Allocation should be contiguous. Okay, So we have second condition over here. Allocation should be contiguous. What do you mean by this? That if this is your sample input 20, 12, 34, 67, and 90, what you need to do is you cannot choose for student one a book with page 12, take 12 pages and with page 67. No, you cannot do that. What you need to do, you need to go it in contiguous manner. Like if I try to explain it to you with the help of this sample input, there will be only three permutations. First permutation will be this one, where student one gets 12 and rest of the the second student gets these three books. The next permutation will be to break it in exactly in the middle, okay? And obviously the third one will be to take first three pages from here and the last one, first three books to the student one and the last book to student two. So we only need to consider these three permutations, and that is what explained over here also. Like first permutation is of 12, 34, 67, and 90. Okay, so let me explain it to you. Let me clear all of this. Okay, so if you look at the first permutation, your student one will get 12 pages and your student two will get 191 pages. Okay, similarly, if you look at your second, this one will be getting 46, 12 plus 34, and this one will be getting 157. And third permutation, your first student is getting 113 and this one is getting 90. Just to confirm, let's add it. See, I would have taken simpler numbers. I agree with that, but for the sake of sample input already given to us in the question, I have not modified it. Okay. So 12, 34, and 67. We have 113. Okay, right. So what you need to do, you need to take maximum out of each permutation. Okay, so 191 is the maximum over here. 157 is a maximum from here. Okay, and 113 is a maximum from here. Now, out of these maximums, what is the minimum? So 113 is your minimum. Hence, this is your answer. Okay. So first maximum of all the permutations and then minimum out of all of these. Okay. So I hope the question is clear to you. Like if you have any doubts, you can ask me in the comment section. All right. So let's try to frame the logic for this question. Let me take a fresh page. And by the way, I'll be taking same sample input and output to explain you the logic. So if I go here, let me take this. I paste my sample input and output. I'll maximize this. All right. See, these kinds of questions are like at if you're in an interview and if you want to come up with an efficient approach, you should have practiced it before or something similar kind of questions. Okay, because the logic which I'm going to show you right now, you will realize that in an interview thinking about that logic is not so easy. Like I'm not saying it's impossible, but it's not so easy. Okay, so let's have a look at it. So over here we have two students, four books, and we need to first we have already seen we have taken these three permutations, the maximum value out of them, and finally the minimum out of them. Okay, all right. So can I say that if I take a, let's say, a number line. Okay, if I take a number line, what could be the maximum value of my answer? Like for the time being, let's consider it as I am not giving any book to student one, suppose, which is not correct. I know that, but for sake of explanation, I'm saying why it is not correct, because it was given in the question that at least each student should take one book. So what is the maximum number of pages student one should take? It should obviously be non-zero, but for the sake of explanation, I'm doing it. You can improvise it if required. All right. So maximum could be like I'll be giving all the pages to one student, okay? Like all the pages to one student. The summation of this comes out to be 203 if I'm not wrong. Let me just check. 12 plus 34 plus 67 plus 19. Right, so 203. So what is this 203? This is my maximum range of my answer. Because see, what could happen? Like in worst scenario, what could happen? You are going to give n minus one books to a student and any one book to another student. But I am taking more worse than that. I'm saying, okay, fine. I'm not giving anything to one student and I'm giving everything to the other. So any one of them needs to read them all, right? And what could be minimum? Minimum could be similarly zero, like no pages are read by anyone. Although this is not exactly the limit will be somewhere in between because student one or student two will be taking some non-zero, some reading some non-zero pages. So you will have your minimum somewhere over here, maximum somewhere over here. But I have just extended it a bit. I've just extended the range a bit, which will not affect our time complexity as of now much, but you can obviously improvise. Okay. So we'll see. Like if required, we'll see. But going with this approach, like 0 and 203 makes the concept grasp in a very easier way. Okay, like this is a very nice concept. Let's start with it. So I know that my final answer range is somewhere between 0 to 203. Can I say that if this is in between 0 to 203, I need some logic to narrow down my range, like somewhere if I some logic to narrow down my range, or somehow, let's say I converge to some number in between 0 and 203, which is my answer. Over here, obviously it's 113. So let's see that approach. How can we do that? So we are going to apply binary search over here. Okay. Now make sure you understand that the input array is not sorted. Okay. And whatever we are doing right now has nothing to do with sorting, but still we are applying binary search. Okay. So these kind of questions are basically binary search on answer. Okay. It is a category of questions which says binary search on answer or on value. So let's have a look at it. Let me take the mid of 203. So it's an integer division. Okay. So if you carefully observe, and it will come out to be 101, but like if you want to do it comes out to be 101.5, but it's an integer division, like if you implement it in Java or C++. So let's take this as 101. Okay. Now what I'll do, see, listen to this part of the lecture very carefully. What I'll do, I'll assume this as my answer. Okay. I'll assume this as my answer. So if I assume this as my answer, can I say that student one can maximum read 101 pages? Like if you carefully observe, how was our sample input looking? The explanation of sample input. We took the summation of this as 191, right? Over here, the summation of this was 157, and over here, the summation of this was 113. So what we were doing, we were basically taking the maximum pages allocated to a student in that particular permutation. So over here, I am doing something similar. I will be saying that I can allocate at max 101 page to any student. Okay, so let's have a look at it. So if I take 12, okay, if I take 34, 12 plus 34 is still less than 101. But as soon as I take 67, what does it become? It becomes 113, which is greater than 101. So what we need to do, we need to pass this 67 to second student. So if I go over here, I make it 67. Okay. I make it 67 to student 2. I again check, is my 67 less than 101? Yeah, it is. So I can proceed forward. I will take this 90 also to student 2. Now if I take this 90 to student 2 as a whole, this becomes 157, which is exceeding my maximum range, or rather you can say the maximum value right now. So what we need to do, we need to take this 90 again to student 3. Now what has just now happened with the value 101, we need at least 3 students. But in our question, what do we have? We have only 2 students. So let's try to think in a logical and practical manner. Can I say if I increase the number of pages for each student, I will require less number of students? Making sense, right? So what I'll do, in binary search, we have start, right? We have end and you have mid. So in these kind of scenarios, I will make my mid pointing to start plus, uh, just a second. I'm sorry. I'll make my mid start pointing to mid plus one. Okay. So what will happen right now? Our start will become 102. Okay. This will come over here. This start will come over here. It will become 102. And your end is still over here. We calculate new value of mid. Okay. So if you calculate new value of mid now, let's do it. So let me open the calculator. So this is 102 plus 203 divided by 2. So it's coming out to 152.5. It is integer division. Let me take 152. Okay. Now we have 152. We'll do the same operation again. What we'll do now? We'll take student S1, start allocating books 12 less than 152. 12 plus 34 still less than 152. 12 plus 34 plus 67. Okay, 12 plus 34 plus 67. It is still less than 152. Let's take 90 also. Now it is exceeding 152. So what I'll do, I'll take this 90 for student 2. Now what we observe over here that we are able to allocate all the books only to 2 students. So this could be my possible answer, right? This is a possible candidate for my answer. So if I take a variable answer, I'll store this 152, but I will still try to search for more optimal answer. Can I get less number of pages? Can I do better than this? Yes, obviously we can. So what we'll do, we'll point our end to mid minus one this time. Means our end will come from here to here. Okay. So our end will become mid minus one. Right. So what was your start? Your start was 102. Now your end has become 151. So let's calculate the new mid once again. Okay. So let's do it. 102 plus 151 divided by 2. So it's coming out to be 126.5. So it is somewhere over here, right? 126.5. Let me write it with a different color. Let me take this color. Let's take 126 because it's an integer division. Now we do the same check again. What we do? We take S1, 12 less than 126, 12 plus 34 less than 126, 12 plus 34 plus 67, still less than 126, 90 greater than 126. Means when I add 90 to 12 plus 34 plus 67. So we take this 90 to S2. And now you're able to allocate this. So now what I'll do, I'll update my answer from 152 to 126, but I will still go on and on searching for better solution. And we have already seen 2 scenarios, like what is important in binary search. 3 things: what is your start, what is your end, and what is the logic to move right or left so that you can narrow down your range. We have seen all those 3 things. And once we narrow it down, there will be a point where we will exceed, or where our end will exceed start. Okay, something similar to this. Like if I have this range, our end will come over here and start it will be over here. So our end is less than start now. So this is the point where we'll be coming out of my loop and finally returning our answer. So I hope this logic is making sense to you. Like we are trying to target number of students, how many students do we have with the certain number of pages that we have decided to be read. And if the number of students is less, we will in if the number of students is less, like suppose in this case, let's say let's say your student one was only able to read everything. Okay, suppose I'm taking a hypothetical scenario. Then what we need to do, if student one is already able to read everything, then we can mm, improve our answer to a better extent, because we need to compare, right? Or just a second, if it is becoming too confusing, let me explain it once again. Hold on. I told that we are initially taking one mid value, which is our possible answer. Okay. And with this mid value, I am checking how many students I require. Okay. How many students I require such that I can allocate all the pages. Okay. If this is not matching, if this is not matching with m equals to 2, then we were doing some operation. Let's say we take that operation as O1, and if it is matching with this 2, okay, if let's say we only require S1 and S2, if it is matching with this 2, then we were doing some operation, let's say O2. So if it was matching with this 2, I was trying to improvise my range further, right, by making my end equals to mid minus 1. Like I'm trying to shorten my range. But if it was not matching with this m equals to 2, or when we were requiring more number of students to accommodate, then what we were doing, we were trying to increase our number of pages such that each student reads more pages. Hence, our range, or our number of students will required will become eventually less, and we will be able to arrive close to our answer. So I hope the logic was clear to you. Now I will go through the code, and that will make things crystal clear. Okay, so let's have a look at it. So yeah, let me maximize this. Yeah. So we have a method find pages in the Java code, which is taking our given array, which is the array of number of pages in each book, how many books you have, and what is the number of students, with denoted by this small m. Okay. Now we have taken a sum variable. Why we have taken, we'll see. Let's try to understand this first. So it is saying if your number of students is, or sorry, if your number of books is less than number of students, okay, then obviously there is no solution. Why? Because if you remember, I told that if there is S1, S2, S3, three students, then each one of them should get at least one book. But what it is saying, that your books is already less than the number of students. Like there are only two books, B1 and B2. Then this S3 is left without any book, right? And this is violating our constraint. Hence, we are returning -1 from here. After that, I have run a for loop on our array and done the summation for all the elements. Why? To decide the maximum range. Okay. I have taken the start as 0, end is my sum. I've taken a very large value for answer. You can take means the max value, okay, integer dot max underscore value in Java. After that, as this is a binary search, so you need to make sure that you only go when your start is less than or equals to end, right? Now let me explain this to you. Already I've explained it in the logic, but for clarity purpose, I'm calculating the mid. This is possible is the check, is the check for seeing whether I am able to accommodate all the possible books, all the books in the number of students given to me or not. Okay, if I am able to do it, then I will try to improvise my answer. So for improvising, what I am doing, I am storing the value of mid, which is my current answer, okay, which is my current answer, because it is possible. If it is possible to do the arrangements with the help of m students, n books, then I know that it is a possible answer. So I'll be storing it. And if you carefully observe, we have a ternary operation over here. If my answer is less than mid, so initially, obviously, answer will be less than mid. Uh, no, I mean to say, if it is less than mid, then have answer it as it is, or otherwise updated with mid. Okay. So yeah, and you are doing end is equals to mid minus one. Why? Because we were trying to get a more better solution, more better approach. If you remember what I'm saying is, there is your start, there is your end. Let's say with this mid, you are able to achieve what you wanted. What you wanted, you have if you have n books and m students, you are able to allocate with the help of this mid all the n books to m students. Then you will try to shorten your mid. And what is this mid, by the way? Like already I've explained in logic, but this mid is nothing but your number of pages, or rather I can say max number of pages, okay, in any permutation, whatever permutation you take out of all the books. All right. So if it is yes, then you're storing it, okay, and you're also finding your minimum every time. Like this is a while loop, right? So you also need to keep a check that you will only update your answer when you get next time a value smaller than it. Okay. All right. So in the else part, it's pretty straightforward. Like if it is not possible, then what you need to do? Then obviously you need to increment your number of pages, right? Because what would have happened? Why it was not possible? Because if this was the case where m is equals to 2, you were able to allocate it with 3 students. Suppose you were able to allocate it with 3 students. So this is the case where it is not possible. So can I say if I increase the burden on students, or rather if I increase the number of pages, I can get rid of this S3. So how do you do that? You basically make your start pointing to your mid plus one, and you get your new mid somewhere over here in between. So your mid is getting increased, or can I say the number of pages maximum in the permutation is getting increased, right? So this is the else part for that. Okay. All right. So let's proceed forward. Let's come down. Okay. Yeah. So this is the crux of the solution now. I hope the binary search was clear. So in is possible, what you are checking, let me explain it to you. So initially we are assuming that, let's say the student required is 1. Okay. Current sum is 0. We are running a for loop on our entire ARR. Okay. And at the very starting, can I say if the current number of pages in a book, okay, in the very first place itself, if it is greater than my expected, or if I go up current main, see what we are passing over here, we're passing mid, right? So in mid, I have my current main. So if I try to show it to you with the help of an example, it will look something like this. If my current ARR is, let's say, 152, and your current min is 101. So you are saying that I will give only 101 pages to means maximum pages to a student, but your first book itself contains 152 pages. So there itself you are returning false. No, it is not possible, right? After that, what you're doing, let's say if your current sum plus ARRI is greater than current min. Okay, in order to appreciate this, let's first go to the else. Okay, we'll come to this part of the code. See what is written in else. Otherwise, you're simply summing up your ARRI with the current sum. So what you're doing basically, if I take the example as 12, 34, 67, and 90, you are adding all of this. Okay, you're adding all of this, and you're again going to the top. Okay, in every iteration, you're adding at that particular value, at that particular I, what is the value in ARR, and you go to the top, you check ARRI again, which I've already explained. And what you do current sum plus ARRI greater than min. As soon as this is true, you know that you require one more student. Let me explain. Let's say I take 12, okay? And this is my 101. This is my current min, okay? This is my current min. Let me remove 152 as it will confuse you. So this is my current min. I have taken current min as 101. I come down, and what I find is that my error I is not greater than current min, so I don't return false. I do current sum plus error. I check if it is true or not. So what is current sum? Current sum is 0. 0 plus error. 12 is not greater than 101. I don't do anything. I come over here. I add to my current sum the value 12. Okay. Similarly, I'll go up and I'll again add 34 to it, so it becomes 46. Because still this will be false. Okay. And after that, once I add 67 to this, okay, what I'm going to see is 46 plus 67. Once I add this, how much is this? 46 plus 67 is 113, I believe. Yeah, it's 113. So now it got exceeded, right? So your this condition will become true, and you are well aware that you need one more student now because your first student cannot take 12, 34, and 67. This 67 should go to the next student, right? So that is the reason you have again initialized your current sum with error I, and there itself you are checking, has my student required got incremented by m? Like, am I able to do it with m number of students or not? So in this case, our m was 2, right? If you remember, while the code which I was explaining. So if it is exceeded over there itself, you need to return false, right? And all of us know right now like why we need to return false and what will happen. So if you return false, you go up. Okay, you go up and you come to this part of the code, right, where you increment your start to mid plus one, increasing the burden on students, increasing the number of pages, right, which will let's say decrease your uh, sorry, increasing the burden on students and increasing the number of pages on each of them, because what you do, you have made your just a second. Yeah, you have made your you have made your start to somewhere over here. Now it will take this mid. Okay, so that will obviously decrement the number of students, and you have a possibility to match your final value of small m, right, which was the number of students given to you. So I hope the intuition and the logic behind this is clear to you, and at the very end it will obviously converge to your exact answer. Okay, you can solve this problem in our practice portal of Geeks for Geeks. I will have the link of the problem in the description. Okay, let's try to compile it. Okay, so we have some bugs. I think I have by mistake done it over here while explaining. Okay, so you got your sample output as 113. Okay, which is correct. And submit. Let's see. All right, so there you go. You get the correct answer, right? So I hope the code is clear to you. So see, in these kind of questions, what you need to do is you need to first understand your question carefully. Like, trust me, it will scare you in an interview if you look this big problem description. Okay, if you have this big problem description, then it might scare you. It's pretty obvious, right? So what you need to do, you need to break your question in parts and you need to understand it step by step. Okay, try to think harder. Okay, how you can do what you can, what conclusions you can get from each part of the question. Like over here, if I tell you like what was the most important line, which at least I felt, which helped me in reducing the number of permutations, is this one: allotment should be in contiguous order. Because if this was not the case, then I could have taken the books like in any order, right? The pages of the books in any order, right? Which is actually, which will actually increase the complexity of my code, right? So you need to understand this in these kind of questions. And yeah, I hope the code was clear to you. Like if you have any doubts, you can let me know in the comment section right now. See, and this is a very important line. Like whenever it is possible, you know that you have some answer, so you're storing it, and the next time you're comparing it with again, like what is your current mid, and if your answer is less than mid, then only you're updating it with the answer right now. Otherwise, you're keeping it we'll update it with mid, right? So basically, we are improvising. Like if I go to the whiteboard where I was explaining it to you, initially we came up with 101, right? Then we went to 152. Then we went to 126. Okay, and these way we were going to this part. Okay, so we knew that 126 could be one of our possible solutions, but we tried to make it more better, right? We tried to make it more better. So, or if you want, I can show it to you one more time. How come 126 was a possible solution? So what I told, like if there is S1, I can take 12, I can take 34, because 12 plus 34 is still less than 46. Sorry, still less than 126. What is that after that? 67. So 12, 34, 67, it's coming out to be 113. I can still take it, but I cannot take 90. So I move this 90 to S2. So see, I'm able to allocate all the books to two students, right? But I can still improvise it. I can still make it better. That is the reason the logic for that answer is written over there. Like if you get a better value, please update it. Okay. So yeah. All right. So I see that we don't have any questions. So that's it for today, guys. We'll come up with some more interesting problems of product-based companies, okay, in our further lessons. I'll stop my live session right now. Thank you for joining Geeks for Geeks practice.